Okay, now that we have established a definition for the imaginary unit and some powers, we know that I is equal to the square root of -1. We're going to utilize that fact to simplify other roots. And so an example might be simplifying the square root, I'll put it over here, square root of, let's say, -9. Well, the square root of -9, if you remember how we simplified roots a few sections ago, you can split up the number under the root into its factors. And as long as you have perfect square factors in here somewhere, it simplifies nicely. So if I take this square root of -1 and the square root of 9 separately, I get I and 3 when I simplify them. Or I'm just going to call it 3i. Whoa, let's move that on the screen. There we go. So we'll just call that 3i, right? I times 3 is 3i. In a similar way, if I were to take the square root of negative, let's go with 25. Well, that's the square root of -1 times 25, which of course is the square root of -1 times the square root of 25. That's 5, and that's I, so that's 5i, right? So very simply we can get some more radicals to simplify. You know, the square root of -100, you could obviously see is 10i. You take the square root of the number and tack the I on. Okay, so these aren't too bad, right? The square root of -16/49 is, well, 16/49, the square root of that is 4/7, and the negative becomes the I. Okay, so it's 4/7 I. Alright, so definitely simplifying some negative roots is kind of nice, but we can even go further than that. I'm only doing perfect squares here, but let's say we were looking at some roots that were not perfect squares, something like the square root of negative, let's go with 20. Alright, maybe this one I'll run vertically. Square root of -20, I can separate that off again as a -1 times a 4 times a 5. So I'm splitting up the 20 into a perfect square factor and then taking the square root of each part. Of course, this first part is I, the second part, what did I just do? That should have been a 4 under there. I'm sorry, I'm jumping ahead of myself. That should have been a square root of 4. Square root of 4 is 2. That's where I was getting that from. And then this is a square root of 5. So ultimately, my answer, when I write these out, we tend to like the root on the end so that it doesn't look like other things are in it. So the root usually ends this off, and the whole number usually comes out front. So we're going to call this 2i times the square root of 5. If I write the 2 or the I after the square root, sometimes it looks like that root goes over top of them, and we don't like to do that. So let's take another example. Maybe I won't make a mistake like that. Let's do square root of negative, let's do like 63. Well, 63 is 9 times 3, I'm sorry, 9 times 7. So this becomes -1 times 9 times 7. And again, the square root of the -1, we get the square root of the 9, the square root of the 7. This first part is I, then you get a 3, then you get root 7, and so we put it all together, it's 3i times the square root of 7. Right, so that's our simplifying of radicals. Essentially, it's the same thing we've seen in the past with simplifying radicals, except now if there's a negative under the root, it becomes the I outside. Okay, and that happens every time. Even up here, the negative under becomes the I on the outside, and so forth. Okay? Okay, so now what's interesting about this is that you're seeing real numbers multiplied by the imaginary unit. right? 4/7 times I, 3 root 7 times I. The 3 and the root 7 are just a real number times the I. And so we have two types of numbers. They are imaginary numbers and complex numbers. All of the ones that we just looked at are called imaginary numbers. They are a real number times an imaginary number. Okay, a real number times an imaginary, I'm sorry, the imaginary unit. Okay. We're also going to see something called complex numbers. And complex numbers are a combination of real numbers and imaginary numbers. Okay, in fact, complex numbers are always written in the form a plus bi, where a and b are real numbers. Okay, so some examples of complex numbers are things like 2 plus 3i. Here you have a real number and an imaginary number added together. Now it is possible for a and b to be 0, and so complex numbers can include things like 5, right? Because 5 is 5 plus 0i. So all of our real numbers are actually included as complex numbers. And you can also have things like negative 7i, because that's like 0 plus negative 7i. So even imaginary numbers are complex numbers. So now complex numbers include real numbers, imaginary numbers, and the combination of the two. Kind of interesting. Okay. So for the rest of these videos, what we're going to talk about for this section is doing arithmetic with these complex numbers. We're going to add, subtract, multiply, and divide them. And what you're going to find is that we treat them almost exactly like polynomials. Think of the I like a variable, like an x. The only thing is, we're going to get to a point where sometimes we have to square the I or raise an I to a power, and then we're going to need those powers from the last video to simplify those.